All right. Hello. Good morning, everybody. So, how was your weekend, guys? Sino ang nag-work kahapon? Di ba, we agreed that yesterday would be a holiday, and I don't. I think nobody submitted the homework yesterday, so that's good. So, how about you? Did you had a good weekend? Okay. Ayaw niya talaga mag-share, no? Small talk muna tayo sa simula. Yeah. How is homework 3 going on? I saw probably 3 or 4 students already submitted their work. You are in a good shape. But anyway, the deadline was extended until Wednesday, so you still have about 3 days to finish it. So yeah, and then you only need to submit 4 out of the 6 problems. So we'll have only 20 points for this homework. So you can choose any of the 6 and submit which one you are most comfortable with. So yeah, and then for today, you are all up to business. So probably we can start. We'll continue on browsing through module 2, but unfortunately there is a major typo. So I hope those who already submitted your homeworks saw that major mistake that I committed. There was a typo in definition 6, as we will see later. But if you already submitted your work for problems, I think problems 4, 5, and a little bit of 6 might be affected with that typo. So if you follow definition 6 and for your homework problem numbers 4 and 5, or probably also 6, you can just resubmit your work via email. Then for succeeding homeworks, I'll change the settings so you can edit it anytime before I grade your homework. All right. So sino ba yung nakapansin ng typo? Somebody called my attention on that. I forgot just who it is. If I remember, I'll thank her or him later. But I hope you guys caught that mistake. Let's see. May nakapansin ba na iba? Or you abided by my request to take the Sunday off, so you guys didn't do anything yesterday, which is fine. So let's see. Let me start sharing, and then let's discuss module 2, the rest of module 2. Okay, so last time we talked about linear independence or linear dependence, and we saw several ways of checking whether a given set is linearly independent or linearly dependent. But almost all of them will start with considering the homogeneous. So you take a linear combination of elements of your set, equate it to the 0 vector, and see if you can find scalars not all equal to 0. If you will find a set of scalars not all of them equal to 0, then that qualifies as a linearly independent set. All right? Sorry, linearly dependent set. Lagyan na dito sa dependent and independent. Hold on, let me just accept people from the lobby. Okay, guess here. And you start considering the homogeneous equation combination equated to the 0 vector. Of course, if you will set all scalars equal to 0, then that would be a solution. If that is the only solution, all scalars are necessarily equal to 0 for the homogeneous equation to be true, then your set is linearly independent. However, if you can find a set of scalars, at least one of them is not equal to 0, then that means your set is linearly dependent. All right. And then we said this will play a role because we have seen via Steinitz replacement property that if your set is linearly dependent, then at least one of its members can be written as a linear combination of the remaining other elements in the set, and vice versa. So that means carries no new information about the structure of your vector space or of the set being considered. So that's why we can drop that element because all information it brings can be derived from the other elements in the set. Kaya tinitingnan natin yung linear dependence and independence. And that's why it's called linear dependence. A set is linearly dependent. You can remember it this way. If one of the elements, at least one of the elements, depend on the other elements via linear combinations. Otherwise, if none of them can be written as a linear combination of the other, then that means that your set is linearly independent. So kaya mas gusto natin yung set to be linearly independent because we said the larger the set is, the more likely it is to be linearly dependent. The smaller the set is, the more likely it is linearly independent. And of course, it works to our advantage because we want to have the least amount of vectors in order to understand the vector space itself. So we can eliminate from the vector space or from our consideration those that linearly depends on other elements of the set. So parang papalitin si set V para po konti na lang yung vectors natin pag-aaralan. Paano natin siya papaliitin? Tatanggalin natin yung mga vectors na nagdedepende lang naman dun sa ibang mga elements ng vector space. So that the set of vectors we will study will be smaller and smaller and smaller. And that brings us to definition 6, which is the definition for a basis of a vector space. So let's look at it. It says here that if V is a vector space over the field F, then a subset V of V is a basis of V. And take note of the use of the article a instead of the. There's an implication here that there might be more than one basis for a vector space V. Now there are two conditions for that set or subset of V to be a basis. Number one, V should be linearly independent. And there's where my major slip-up happened. So you guys please correct page 17 of module, it's definition 6, condition 1. It should say that V is linearly independent, okay? So I bragged about this earlier in the first few parts of the module that we want as little a set to consider in studying the vector space. And one strategy is to take away all those elements that linearly depends on the other elements. So it doesn't make sense to consider a basis that is linearly dependent because that will be a huge set, right? And there would be extra elements or redundant elements. So here, we want the set B to be linearly independent. So kindly again, correct this in your modules. Let me just pull up the page number. Definition 6 is on page 20 of your modules. So this should be linearly independent. And again, for those who just came late, for those who didn't notice this and use the original statement of definition 6 in homework problems 4, 5, and possibly 6, you can resubmit your work via email. Just let me know that you didn't catch that typo or that major mistake I had, so you can resubmit your work. So dapat B is linearly independent. And in the second condition, simply says that the set V is generated by the basis or the set V. So every element in the vector space should be written as a linear combination of elements of the basis. And now you see how nicely constructed bases are. So napakaganda ng pagkaka-define dun sa basis. Let's start probably with condition 2. What does condition 2 imply? Condition 2 implies that every element of the vector space can be written as a linear combination of the basis elements. So ibig sabihin, kahit ano pa vector element ng vector space, isa lang siyang linear combination ng mga element ng basis. Therefore, even without knowing what the entire vector space is, or without knowledge of all elements of the vector space, we can generate all of them by simply taking into account all possible linear combinations of the vector space. And you imagine that the set B might be very big. If we will just put that condition 2 alone to be the condition for a basis, then the set B might be big. It might be the entire vector space itself, right? Because L of the vector space is equal to the vector space itself, right? So parang walang sense yung pagpapaliit ng set ng pag-aaralan natin if you will just consider condition 2 to be our definition for a basis. Uh, the, the nice implication of condition 1 is that we are considering only those vectors that are not redundant in nature. So condition 1 and condition 2 guarantees that we are considering the smallest possible set that preserves all the properties of the vector space as an algebraic structure. So, kasi linearly independent, wala na yung mga redundant elements that carries no more information or no new information, while maintaining the capability of that set or the elements of that set B to generate all elements of the vector space. Kaya ang tawag sa kanya ay basis. So parang siya yung nagiging basehan ng buong vector space because it is the most efficient, because it is linearly independent, there are no redundant elements, and they can generate the entire vector space. Okay? So, minsan ganun sa math, minsan kailangan yung mag-isip ng magandang paraan paano maalala yung mga terms. And usually, terms in math are not randomly given. So there is a reason why they are named so. For instance, basis. Kasi parang siya yung pinaka-basehan ng vector space. Kasi lahat naman ng elements kaya mo isulat as a linear combination and there are no redundant elements. That's why it's a nice set to consider if you want to study the structure of the entire vector space without having to consider all the vectors in the space. And then linear dependence, linear independence. So lagi silang meron silang parang creative, there is a creative reason or there is a technical reason why why they are named so. Right? So that's the definition of a basis. So and then here are some nice properties of basis that will tell us about its property or its nice properties. So proposition 8. So you have a vector space over a field F and curly B is a subset of V. So note that the assumption of proposition 8 doesn't say that B is a basis right away. So it just consider B to be a non-empty, to be a subset of V. Then the following remarks are equivalent. I hope you guys remember how to deal with equivalent statements, right? So B is a basis of V. B is a maximal linearly independent set of V. Then B is equal to B. And probably I should put ifs here. And then I should put an if also here. Probably B is a minimal generating set for B. Okay, so there's also an if here for condition 3. All right. So this three statements here are equivalent in the sense that if 1, if and only if 2, 2, if and only if 3, and 1, if and only if 3. So actually, this proposition is a bunch of 3 theorems in disguise, all right? And actually, not just 3 theorems, but 3 biconditional assertions. So, ibig sabihin, parang 6 na theorem in all yung binibigay ng proposition 8. Because when you say that the following statements are equivalent, then that means 1 if and only if 2, 2 if and only if 3, and then 1 if and only if 3. So, yun yung equivalence. So, equivalence can be thought of as a biconditional assertion. So, if you want to prove it brute force, then what you'll need to do is to prove that 1 implies 2, and then 2 implies 1, and then you also need to show that 2 implies 3, and then 3 implies 2, and then 1 implies 3, and then 3 implies 1. So I hope you guys now know what this assertion means. So if you want to prove, say, 1 implies 2, you need to assume that statement 1 is true. Then you should be able to derive using logical arguments that 2 is also correct, or 2 is also true, right? And so in order to prove this, or one way to prove this, this proposition is to prove these 6 little theorems para ma-prove yung equivalence of those statements. But in logic, there is an easier way. Instead of proving all these 6 implications, we only need to prove 3, but just put them into a sort of a circle or a cycle. So instead of all 6, you can just prove, oops, you could just prove probably 1 implies 2, and then prove that 2 implies 3, and then prove that 3 implies 1. Something like that. So para magiging isa siyang malaking cycle of implications. So this is another way of proving the equivalence of the 3 statements. So prove that 1 implies 2, 2 implies 3, and finally 3 implies 1 to complete the circle, right? Or you can rearrange things here. You can prove that 1 implies 3, and then 3 implies 2, and that 2 implies 1. That's also valid as long as you have a circle going on in here, right? So, minsan kasi mas madaling i-prove or mas obvious ang implication from 1 hanggang makapunta ka kay 3, then kay 3 papunta kay 2. So, pwedeng ganon, as long as you will get a pattern of this sort, right? Now, this theorem involves several terms. It says here, maximal linearly independent. Pag sinabi mo maximal linearly independent, ibig sabihin siya yung pinakamalaking set na linearly independent. Pinakamalaki in a sense, not merely due to numbers, but it is not contained in any other linearly independent set. That's why I was thinking earlier, if I want to show the proof of proposition 8 or discuss it in details, because it has, it involves some terms from set theory. Maybe a show of hands. Since hindi nakarinig na or naka-experience na proving statements involving minimal and maximal sets. Let me see, just to give me an idea. Because I am not planning to discuss the detail of this. Say something about this later. But wala pa nakapag-work with maximal and minimal. So they are called maximal and minimal. Again, lagi yung mga terms sa math, lagi, most likely meron niyang reason kung bakit yun yung tawag sa kanila. Maximal, you can think of it as the largest set. Largest set in the sense of inclusion. Meaning, if it is a maximal set among a set of sets, ibig sabihin siya yung pinakamalaki, it is the biggest set satisfying a certain property in the sense that it is not contained in any bigger set. So, halimbawa, meron kang set A, tapos meron akong bunch of subsets A1, A2, A3, and then A4, A5, A6, and probably an A7 here. All right. Okay, so you can try to arrange the subsets. Say the subsets are A1 until A7. Arrange them in a tree based on inclusion. So, ibig sabihin, magkaka-connect yung mga subset ng bawat isa. So, of course, A1 is a subset of the big set. But here, in my drawing of inclusion, so let's call it an inclusion tree. I just forgot what the right technical term is, but a set is on top or nasa taas yung isang set kung subset niya yung mga nasa ibaba. Right? So that means A is a superset of A1, and then A1 is a superset of A2, and A2 is a superset of A3. And of course, you know that being a subset or a superset is transitive. So that means A1 is also a superset of A3, meaning A3 is contained in A1, right? But you see that A4 is not connected to A3. In this 3, that means that A3 is not a subset of A4, all right? Then A7 is only here, even though it has the largest cardinality. So say this is cardinality, say 5, 4, 3, 1. And of course, the empty set is a subset of everything. So kung bubuuin ko yung 3, pwedeng ganito yung itsura ng inclusion 3. Alright? So though that A7 is the largest subset because it contains 5 elements, wala siyang ibang kasama dun sa inclusion 3 because probably there are elements of A4 that is not contained in A7. So walang nasa ilalim si A7 aside from the empty set. So, okay. Now, what are the maximal elements? Maximal elements siya kapag wala ng proper subset na nagko-contain sa kanya. So that means A1, A4, and A7 are maximal subsets. Right? So they are maximal subsets because they are subsets that satisfy a certain property and they are not contained in any other proper subset. So dun sa chain niya, siya yung nasa pinakataas. So that's what is meant by being maximal. And you see that even though A7 has 5 elements and A1 has only 4 elements, we say that both A1 and A7 might be maximal subsets because A1 satisfy the given property that I want, but it is not a subset of A7. That makes A1 maximal. A4 is also maximal because it is not contained in either A1 or A7. So siya na yung sunod dun sa parent set in the inclusion 3. And then the minimal elements here are the non-empty subsets A3 and A6. They are minimal kasi sila na yung pinakamaliit na sets, na non-empty sets doon sa kanilang inclusion chain. So that means it doesn't, A3 and A6 don't contain any set satisfying the given property. So A3 doesn't have a non-empty subset, so that means A3 is a minimal set. A6 is also minimal because there is no non-empty set contained by it that satisfy a certain property. And what do you think about A7? Can I consider A7 to also be a minimal set based on this inclusion 3? Anybody? Okay, yeah, thank you, Sir Dexter. That's right. A7 is also minimal because there is no other set below it, non-empty set below it that satisfies. Yeah, there is no other non-empty set below it. Okay, so a set can be maximal and minimal at the same time, and a maximal and minimal set is not unique. So nakadepende siya on how the chain of the inclusion 3 looks like. All right. So going back to our statements, so ibig sabihin, if you have your parent vector set, vector space, and then if you list down all of its linearly independent subset, okay. So posibleng meron ka ditong set B, meron ka ditong set C, meron kang set D, set F, set G. Kunwari, yan yung mga linearly independent subsets of the set V, right? So that means that B is a basis is equivalent to saying that B is a maximal linearly independent set of V. That's what proposition 8.2 is telling us. So if we will order it into a chain, so that means that B is not contained in any other linearly independent set. So that means posibleng ganito yung itsura ng chain of subsets. So pwedeng ito, si F nandito pala, pwedeng si G, nandito lang siya, right? So that means that if my chain looks like this, then B is a basis if it's a maximal linearly independent set of of the vector space, right? And then also B is a basis if and only if it is a minimal generating set for B. So kung ililista nyo naman yung generating set of V. So let's say you have B, C, D, E, and F. Proposition 8.3 tells us V would be a basis if and only if it is the minimal generating set for V. Of course, V is a generating set for itself, so it sits on top of the chain. Then, posibleng ganito yung ordering. Posibleng yan, posibleng to generator, posibleng yung E nandito, posibleng yung F nandito. But if B is a basis, then necessarily it must be in the bottom of the chain because it should be a minimal generating set. So, oops, yung inclusion tree, pwedeng maging ganito yung itsura. But here I'm drawing this with only a limited knowledge about the properties of the basis. So, yung palang yung alam po, later we'll establish much more stringent properties of basis that will allow us to draw a more accurate inclusion tree. But for now, what I know is that if B is a basis, then it must be the minimal generating set. So dapat yung pinakamaliit na set na nakaka-generate ng buong vector space. And at the same time, B is a basis if and only if it is the largest or the maximal linearly independent subset. So parang siya yung best of both worlds. Siya yung pinakamalaking linearly independent subset, tapos siya yung pinakamaliit na generator ng vector space. Alright? So I hope you get the picture of that. I won't discuss the proof of this proposition in detail. You can read it here. The trick that I used in proving it, I proved 3 implies 2. And then I went on proving 2 implies 1. And then finally, to close the loop, I proved that 1 implies 3. And since that is a closed loop, then that completes the proof of equivalence. Right? The value for us of proposition 8 lies on the result of the theorem itself and not much on the proof. But nevertheless, I included the proof just to give you an idea how to write about equivalence of statements. Right? And then it will also be a good reading exercise if you'll have time later to familiarize yourself on how to write and read mathematical proofs. Okay. Now, questions? Okay. Now, we said earlier that I think we mentioned last time that if and only statements can be replacement for definitions. But before I expound on that, I think Jeng has a question. I forgot, was it Jeng or Jing? Go ahead.
Jeng, sir. Sir, question po
Okay.
din po sa diagram na dinraw nyo for the maximal and minimal inclusion. Does that follow the principle of creating a lattice diagram?
I don't recall ano nga ba yung lattice diagram, but I think they are related. But sorry, I already forgot lattice diagrams.
Yun yung sa abstract algebra, sir, na parang may set ka dito sa baba, tapos may set ka dito sa kabila, tapos, from bigger set to subset, parang ganun. For the
Yeah,
anyway, parang ganun lang yun. Anyway, sige sir, I'll just read on it na lang.
Yeah. Mukhang related sila. I just know, I just don't know exactly in what context, pero yeah, parang ganun siya. Tapos ganun pa rin yung idea. If that diagram involves inclusion, then ganun pa rin yung maximal and minimal idea ng maximal at saka minimal sets. Right? Now, where was I? Yeah. I mentioned last time that if and only if statements can be replacement for definitions. These results are called characterizations of a certain concept. So that means you can treat any of statements 2 and 3 to be alternative definitions for basis. Right? So pwede kayo definition 6 for a basis where you check two conditions, or you can prove or you can show that the set B is a maximal linearly independent subset, and that is sufficient to show that B is a basis. Because again, this equivalent statement means B is a basis if and only if B is a maximal linearly independent set. So that could be your definition for a basis because it's an equivalent characterization. But I will stick to definition 6. I chose that statement to be the definition kasi siya at least from my point of view, yung pinakamadaling gamitin sa pag-prove that a certain given set is a basis. Right? Para hindi nyo kailangang i-recall sa set theory, ano nga ba yung ibig sabihin ng maximal? Ano nga ba yung ibig sabihin ng minimal? Right? Of course, you can also prove if you can prove that B is a minimal generating set, then that is sufficient to conclude that B is a basis of your vector space. Right? So alternative definitions of basis. That's why I said the utility of proposition 8 is on the result itself and not on it. All right. Now let's go to proposition 9. Okay. Proposition 9 says if you have a vector space over a field F and B is a linearly independent subset of B, then it follows that if you have an element V, a vector V, that is not generated by members of V, then if you add that element to the set D, then the set D, the union remains linearly independent. So let's see, ano yung sinasabi ng proposition na to? So meron kang vector space, meron kang field F, then kapag meron ka daw set D that is linearly independent, then pwede kang magdagdag ng elements dun sa set D that will preserve linear independence, okay? But that vector V that you will add to the set D must not be generated by other elements of the set D. So recall that the proposition 8 tells us that the basis or a basis is a maximal linearly independent set. Okay, siya yung pinakamalaki on its chain na linearly independent set. So if you want to get a basis, one way to do that is to form the biggest possible linearly independent set. And proposition 9 tells us how can we get there? How can we extend a linearly independent subset to a basis? So kung nag-start ka daw sa linearly independent subset, hindi siya necessarily basis kagad kasi mukhang kulang pa siya, right? Kasi kailangan natin maximal na linearly independent subset, right? So you can add elements to D to preserve linear independence, but what is a sufficient condition for that element na idadagdag ko dun sa D to preserve linear independence? This theorem tells us that as long as the vector that you are adding to your set is not a linear combination of the other elements in D. All right? So let's try to prove proposition 9. I guess last time all I do is highlight things from the module. So let's try to prove it from scratch. Hopefully I can recreate the proof para makita niyo yung thought process kesa ina-highlight ko lang yun nandun na sa handout. Okay, so now let's prove proposition 9. Now, how do we prove proposition 9? So proof goes this way. But you can see my thought process and how I write proofs. Right? So my assumption here is that assume what are the premises of the theorem? Of course, vector space V, ang field F, hindi ko na yan isusulat dun sa proof. This is also part of the premise. This might be important. So I'll say that assume that V is a subset of V and V is linearly independent. All right, Li means linearly independent, LD linearly dependent. Okay. Now, also part of the premise or assumptions dun sa theorem is that an element V exists that is not generated by the elements of the subset V. So I will let V be a vector that is not, sorry, it is not a linear combination of elements of V. Right? So this just means that si vector V ay hindi linear combination ng mga laman ni set V. Okay? Then what we want to show is that the union is linearly independent. So that's our goal. From this set of information that we had been given, we want to show that V union the set contained V is linearly independent. Okay. So now, what I'll do here is to do a proof by contradiction. Okay. So proof by contradiction. Now I will suppose that D union V is linearly dependent. Again, in a proof by contradiction argument, you start with negating what you want to show. And the goal is to find a contradiction. So kung gusto kong ipakita na yung set na to ay linearly independent, pwede kong i-assume, kunwari siya ay linearly dependent. Tapos papakita ko na something will be wrong. If something will be wrong with the assumption that the set is linearly dependent, then this statement should be true. Okay, that's the entire point of a proof by contradiction. Right? So now I suppose that D union V is linearly dependent. So by definition of linear dependence, there will exist elements of the set V. Let's call it D1, D2, until Dn, subset of V, and scalars, alpha 1, alpha 2, until alpha n, such that actually linearly dependent yung assumption ko, no? So ibig sabihin, yung mga scalars ay hindi lahat zero. Not all zero. Such that this sum plus alpha v is equal to 0. Right? So this is by definition of linear dependence. Pagka linearly dependent yung set mo, ibig sabihin makakakuha ka ng subset niya na pag kinuha mo yung linear combination ng mga elements na yon, I included V, right? Because V union V is linearly dependent, I can include V inside the set nakukunan ko ng linear combinations, all right? If I take the linear combination equate to 0, then I can find a solution where the scalars are not all simultaneously equal to 0. Okay? All right, so all good so far? So remember, nag-derive ako ng contradiction. Naghahanap ako ng mali kung i-assume ko na ito ay linearly dependent. But what do we know from above? Let's see the list of things that we know about the set. Oh, we know that D is linearly independent. So kung linearly independent si D, then that means here, what?
Scalars not.
Yes, Jen?
There are scalars not equal to 0. Linearly linearly independent pala, sir, no?
Yeah.
All scalars are equal to 0.
So alam ko si D ay linearly independent. So alam ko si D ay linearly independent, so anong pwede kong sabihin sa mga to? Actually, dapat kasama pala dito yung alpha. No? Yung alpha, alpha 1, alpha 2, alpha n, lahat sila ay hindi zero sabay-sabay para maging totoo yung homogeneous equation. Very definition of linear dependence nung D union V. Pero I want to zoom in dito sa linear combination na to. Because from assumption, I know that the set D, oops, not that, I know that the set D by premise is linearly independent. So dahil yung mga DIs nanggagaling kay capital D, so ibig sabihin linearly dependent siya. Linearly independent yung set D. So what can we say about this? Or perhaps we can say something about alpha. Well, can I say that then since D is linearly independent, then alpha is equal to 0. Bakit ko pwedeng sabihin na si alpha ay magzi-zero kagad?
Since one of the definitions of linear independence is that if all the scalars are equal to 0.
Linear independence. Pero mali pala kasi tama. Tama, definition siya ng linear independence. Ibig sabihin, lahat dapat ng scalars ay equal kay 0. Pero linearly dependent yung D union V. Right? Pagkasama si V, inassume natin na linearly dependent siya kunwari for now, right? So that means probably this is not equal to 0. And that's where I want to draw my contradiction from. So can you justify why can I conclude that alpha is not equal to 0? It is necessarily not equal to 0. Ito pala yung disadvantage when I try to write a proof on the spot. So medyo all over the place yung thought process saka yung pagkakasulat ng proof. Pero the nice thing about this approach is that you are with me in the thinking process. So yun yung advantage. That's why I tried last time just reading the proof with you guys. I have a pre-written proof and then we try to read it together and justify the lines. Now let's try it this way. Let's try to recreate the proof on the spot. But the advantage is that you will see the thought process. Pero magiging messy yan kasi ganun ako mag-isip ng proofs, right? But hopefully you can help me organize this as we go along, right? Now, this is a statement that I want to use. Pero kailangan ko itong ma-justify. Kasi makikita nyo later that if I can show that alpha is necessarily not equal to 0, then I can show that V is a linear combination of the DIs. And that will contradict the fact that we assume that V is not in curly L of D. Right? Yun yung gusto kong maging contradiction. But before I can show you that bomb of a contradiction, I need to justify this statement. Bakit? Kung si D ay linearly independent, magpa-follow na si alpha ay hindi equal kay 0 dapat.
Sir, because of our assumption that that one is linearly dependent. So therefore, all the alpha should not be 0.
Since
Linear
and
dependent
since
dito.
Pero kasi di ba yun yung assumption nyo with contradiction, assumption it's linearly dependent. Therefore, if it's linearly dependent, not all alpha should be 0. But it's given that it's already given that this summation of alpha di is linearly independent. So, ibig sabihin, all the alphas here are 0. So, you can't have alpha of the V to be 0.
Oh, but yeah, but that would be a different thing. Kasi pag
Okay.
sinabi mo linearly independent, medyo nakakalito, no? Kasi dalawang set yung pinag-uusapan natin. Ang alam natin na linearly independent ay yung mga DIs. So, kung gusto kong gamitin yung linear independence sa mga DIs, kailangan kong tingnan yung summation ng beta I, I going from 1 to n, i-equate ko kay 0. Then dahil linearly independent yung mga DIs, ibig sabihin dito, all betas are 0. Right? All betas are 0. But these two equations, this one and this one, are two different equations because here I have an additional term, alpha b. And the scalars here and here might be different. Okay? Pwede silang magkaiba. Okay, so kung hindi clear thinking forward, kung bakit dapat yung alpha ay hindi dapat mag-equal kay 0, what will happen if alpha is equal to 0? Because otherwise, probably ito yung naiisip mo, Miss Al, but probably someone is trying to speak also earlier. Do you want to raise your point at this point, or to share ideas? Nahiya na siya or sila. Okay, so pwedeng ganito yung isipin. So gusto kasi, I hope you see why I want alpha to be not equal to 0. Kasi pwede kong isolve saan equal si v. At magagawa ko yon if alpha is not equal to 0, as you will see later. But how can we justify that alpha is necessarily non-zero? Okay. Now, if the forward thinking is hard, okay, then try again contradiction. Ano yung mangyayari kung si alpha is 0? If alpha is 0, then this equation, let's call it star, then otherwise equation star reduces to what? It reduces to this 1 to n alpha I di equal k0 vector, right? Because if alpha is 0, then this guy will be 0, then star will boil down to this simpler equation, right? And if this is our equation, the linear independence of the di's will tell me that all alphas or all alpha i's are 0. So lahat ng alpha i's ay 0, si alpha ay 0. So lahat ng scalars dito kay star ay puro 0. Which cannot happen because we said that linearly dependent yung D kasama si D. Right? So we said that alpha 1, alpha 2, until alpha n cannot all be equal to 0 at the same time. And if alpha happens to be equal to 0, then that means mapo-force na lahat ng mga alpha i's ay mag-0 din. And that will give us only the 0 solution to equation star. So necessarily, si alpha hindi dapat mag-equal kay 0. Alright? Are you convinced with that argument? Or malabo? Any reaction, guys? Or you're still trying to digest this? Guys, are you still there? Am I still online?
So, sir, pwede din pong i-argue dito, sir, that if this is equal to 0, then this one, I mean, ang plus alpha v is the negation of, the summation. Pwede din niyang gamiting argument. Just ask.
Si alpha v ay negation ng summation kung
Para
ano yung first
mag-zero siya.
statement?
Yun. Para mag-zero ang equation to, dapat ang alpha v na to is negation ng summation na to. So if this summation is not 0, then, or so meaning this is the alpha v should also not be 0 or
But I
something. Then,
don't know if the summation is equal to 0.
yeah, ganon, parang ganon.
Yeah, wala pa akong information about the summation being equal to 0. Hindi ko siya makukuha doing that forwardly. Pero sort of related siya dun sa argument, pero hindi siya apparent. So kaya nag-resort ako na, okay, napipwersa na si alpha dapat maging non-zero. Kasi kung mag-zero si alpha, ibig sabihin si equation star ay magiging eto lamang. Right? Because alpha is 0, this guy will go to 0, leaving us only with the summation. Right? So we have a homogeneous equation, which is this one, a linear combination of the di's. So dahil linear combination ng mga di's equal kay 0, necessarily lahat ng alpha i's ay 0. Because by assumption, the di's form a linearly independent set. Okay? So that means we are forced that all alpha i's are 0, and the fact that we said si alpha dapat ay mag-0, that violates the linear dependence ng D union V. Alright? So that means for this equation to be properly true, and at the same time, we agree that D union V is linearly dependent, then si alpha dapat hindi mag-equal kay 0. Okay? So wala pa rin butas, wala pa rin tayong contradiction ngayon. But the nice thing about knowing that alpha is not equal to 0, then I can write alpha v to be equal to negative summation ng alpha I di, going from 1 to n. And then alpha is not equal to 0, element siya ng field na hindi equal kay 0, so meron siyang multiplicative inverse. So I can multiply both sides by the inverse. All right. And then I can use associativity here of scalars, of scalar multiplication. So I'll have alpha inverse times alpha, so there will just be a v here. And then I'll use the distributive property of multiplication in some propositions in the earlier modules. So that means I can write this as negative alpha inverse alpha I, vi, I going from 1 to n, right? Couple of manipulations there. But I will say now that this is a contradiction. Ito yung hinahanap kong contradiction. Bakit siya contradiction? Kasi itong product na to, negative alpha inverse alpha I, these are scalars, right? These are in F. These are elements of V. Elements of V. So that means V will be generated by elements of V, because we have expressed V as a linear combination of elements of capital D, which is a contradiction because we said part of the premise that V is not a linear combination of elements of capital D. And yet, if we will agree that D union V is linearly dependent, then that will be violated. So that forces us to conclude that the conclusion of the theorem, which we assume to be false for the sake of contradiction, must be true. So therefore, D union V, it's not a curly V, is linearly independent. All right? Okay, guys, is that clear? Or at least does that make sense? The approach makes sense? Okay? And you see the power of proof by contradiction here. Yeah, most of the times you'll see proof by contradictions being used. Okay? If that's fine, no questions. Let's see what's next. You can read the more organized proof in the module. Hopefully there's no typo there. And then the next examples, I think, gives us examples of basis for some special vector spaces. So if you remember the set E of elementary vectors in Rn, so here, this example tells us that that forms a basis for Rn. So for example, if you are in R3, a basis could be this set. So this is the set of elementary vectors in R3. So in vector 1, 0, 0, 0, 1, 0, and 0, 0, 1. So that is a basis, the elementary basis for R3. For R4, apat yung elements, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Because remember, elementary vectors, isa lang yung non-zero element niya, and that should be equal to the unity. So ang unity sa R ay 1. So kaya yan yung itsura ng mga elementary basis. So if I ask you for a basis for R3, or if you want to use a basis for R3, then these are the go-to basis. Kasi sila yung pinaka-simple. So these are also called canonical bases kasi sila yung pinaka-natural na basis para sa Rn or para sa R3 in particular. Okay. Now, the extension to arbitrary fields F is also the same. Kung meron kang Z5, halimbawa, meron kang Z5 to the third, so ang basis pa rin niya, tapos ano ang unity sa Z5? Ano ang multiplicative identity sa Z5? 1 pa rin, di ba? So, kung gusto mo ng basis para kay Z5 to the third, ibig sabihin, triples yan. So, anong exponent? 3, tapos kukunin mo ano yung unity ni Z5, ano yung multiplicative identity kay Z5. Multiplicative identity kay Z5 ay 1 din. So, lagyan mo ng 1, tapos the remaining would be 0, and then you consider all the other combinations. For arbitrary fields. Now, example 25 provides us another basis for F3 para sa isang arbitrary field F. Okay? So it says here that 1, 0, 0, 1, 1, 0, 1, 1, 1 is also a basis for F3. And I guess I said here that we already proved that example 18, this is a linearly independent set, correct? And then you can prove that any vector can be written as a linear combination of these three basis elements, all right? So this just showed that pwedeng may dalawang magkaibang basis para sa isang vector space. And hence, I use the article a instead of the article da. Kasi maraming basis para sa isang vector space. Okay. And then also another basis for F3 would be 1, 1, 0, 1, 0, 1, 0, 1, 1, but provided that, however, that F has a characteristic other than 2. So, kasi pagka characteristic 2, ibig sabihin nun, pag meron kang x plus x equals siya kagad kay 0. So, you see that if you will add these three vectors together, you get 0, 0, 0. So, the scalars are 1, 1, 1, not all 0, equals siya kay 0 vector. So, kung ang field mo ay characteristic 2, then this is not linearly independent. Okay. Kasi pag inad mo silang tatlo, makukuha mo si 0 vector, and that is tantamount to saying that it is a linear combination where alpha 1, alpha 2, alpha 3 are all equal to 1. Okay?
Sir, question.
Uh-huh.
Sir, anong
Yes.
parang nalito lang. So, ano itsura ng F3 compared to R3?
F3.
Kunya,
So
sir,
kung
yung field 3 tapos yung real number 3. R3.
yeah, versus R3.
Opo. So, itsura.
Well, F could be any field. It can contain the triples can contain any object as long manggagaling siya sa isang field. So if say F is Z5, so ibig sabihin ang laman lang ni F3 ay mga 3 vectors ng entries niya nanggagaling kay Z5. So ibig sabihin ang laman niya lang posible ay si 0, 1, 4. Pwedeng si 0, 1, 1. Okay? Siya ay na kay Z5 to the cube or Z5 cubed. Pero wala sa kanya si 1, 1/2, 3. Kasi si 1/2 ay hindi element ng Z5.
Okay.
Taken as a number. Right. So, yeah, makikita nyo to, mas magiging familiar kayo dito once you finish modern algebra. Pero usually, in-state ko yung mga results dito in terms of arbitrary fields. But as I promised, most of the times we'll just be considering number sets. Kasi pag sabi mo F3, pwede rin dyan ay set of symmetries. Or yeah, any other field will do. It could be a number set or otherwise, but yeah, as long as field siya. Kaya
So,
medyo
sir, parang sir, mas general si F3 kesa R3? Ganun po ba?
Yes. Yeah, that's correct. Because for R3, you're just choosing F to be equal to R.
Okay.
Whereas F can stand for any other field.
Okay,
Pero
sir.
nakakalito yung notations, no? Kasi
Opo.
pag nagsabi ako ng F3, tapos sabihin ko, elementary basis niya ay 1, 0, 0, 0, 0. 1, 0, 0. That 1 is not necessarily the number 1, pero siya dapat yung unity kay F. So, kaya medyo yung abuse of notation nandun. But don't worry, I won't ask you to work with very arbitrary fields kasi iiwan ko na yon sa modern algebra. Graduate na tayo sa fields after homework 1, so forget about that for now.
Okay.
The nice thing about fields ay yung properties niya. Existence ng multiplicative inverse, kung bakit tayo nakakapag-distribute ng multiplication over addition and so on. But I guess there's a problem in the homework that involves C5, pero I'll give you a hint about that later. All right? Okay. Example 26 gives us the elementary basis or the canonical basis for the set of matrices. So if you have the vector space curly m sub m by n of f, ibig sabihin lang ito sila yung mga m by n matrices na ang laman ay elements ni field F. This example tells us that a base for it would be the matrices with only the unity as the non-zero entry. At once lang siya mangyayari. So, for instance, let me just enlarge the space here. Halimbawa, may ang specific example nito ay say M 3 by 2, say R. So this would be the set of all matrices, 3 by 2 matrices with real entries. So, sinasabi ng example na to that a canonical basis or the elementary basis for this vector space, ayun siyang E kasi elementary basis siya, ay itong set ng mga matrices na to. 1, 0, 0, 0, 0, 0. 3 by 2, diba? So, 0, 1, 0, 0, 0, 0. 0, 0, 1, 0, 0, 0, 0. 0, 0, 0, 1, 0, 0. 0, 0, 0, 0, 1, 0. And then 0, 0, 0, 0, 0, 1. So, this is the set of elementary matrices for M sub 3 by n of r. So you're guaranteed that these 6 matrices here are linearly independent, and any matrix in this vector space is a linear combination of these 6 guys. So if you ever need a basis for this vector space, then probably your go-to would be the set of elementary matrices given here. Okay. Example 27, we talked about this last time. If we are looking at the set of all polynomials with the indeterminate x, then the canonical basis for f bracket x is the set containing 1, x, x squared, and so on. So basically, the set of all monic polynomials form a, sorry, not monic polynomials, but monic monomials. Kindly correct that again. The set of all monic monomials, the set M, is the elementary basis for f bracket x. Siya yung pinaka-natural na basis para sa f bracket x. And there's an explanation here why it is clear that any polynomial is a linear combination of these guys. Kasi last time napakita na natin na linearly independent ang set M. Now this tells us na pag meron kang polynomial p, ibig sabihin ganito dapat yung itsura niya, right? And if that polynomial has this form, then obviously it is a linear combination of elements of capital M. And that completes the proof that it is a basis. Napakita na natin before that it is linearly independent, and we have shown here that any polynomial can be written as a linear combination of the monic monomials, then we're good. M is a basis for f bracket x. And we say that M is, this set M is the canonical or the elementary basis for f bracket x. Okay. Okay. And this might be helpful in one of the homework problems. This is a remark here. In general, the set P0, P1, where Pi is a polynomial of degree I for all I greater than or equal to 0, is a basis for f bracket x. Makukumpleto mo raw yung isang posibleng basis ay kapag ka merong representative yung set of polynomials of a certain degree. So, kumolekta ka lang daw ng isang polynomial of degree 0, isang polynomial of degree 1, isang polynomial of degree 2, and so on. You do that for all degrees. Tigi-tigisang representative siya. Then the set that you will be forming will be a basis for f bracket x. Then example 28 is just a specification of that, or a smaller case of example 27, where we consider f sub n bracket x. So this is the set of all polynomials of order of degree at most n. If you will collect all monic monomials of degree less than or equal to n, then it is a canonical basis. Okay. Now you can remember this and use this in future problems. At least may alam na tayo na basis for some of the familiar vector spaces. Right? Now, why are bases important? So I said that the utility of basis is that it is a very economical way of storing all the information about the vector space. Number one, with the use of basis elements, we can store all elements of the vector space because all elements of the vector space are just linear combinations of the basis elements. So, ma-generate natin sila lahat uses basis elements. And the linear independence of this basis elements guarantee us that this is the smallest possible such set that carries all the information about the vector space V. So this just gives us, I think this paragraph just tells us some of the possible applications. Okay. I'll just let you read this on your own time. Pero yeah, the problem so far that we have encountered is that posible pa lang magkaroon ng magkakaibang bases para sa isang vector space, right? So in most instances, it doesn't matter what type of base, which basis we choose, right? However, in some applications, it is important what kind of which basis we choose. And usually, in those applications, you want the basis to be stable with respect to perturbations in the coefficient. So for instance, si V, actually, yeah. Kung kumuha ka ng basis na, say, B consisting of the BIs, so meron akong basis consisting of the B sub i's. Then one nice property of basis, especially for numerical applications or say numerical analysis, statistics, or even in engineering problems, you want to choose a basis that is stable with respect to perturbations in the coefficient. And what does that mean? So meron kang elements V and V prime, okay, that are expressed as a linear combination of the basis elements. Then in this, in certain applications, we want V and V prime to be close as possible to each other, provided that the alpha i's and the BI's are close to each other. So ito yung stability ng basis. So kapag daw si alpha, yung mga alphas ay malapit lang sa mga betas, it makes sense to expect that V and V prime will be close to each other because their scalar coefficients in the linear combinations are close to each other, right? But there could be very erratically behaving bases na posibleng hindi ganon kalapit si V kay V prime. But ideal situation is when the scalars are almost equal to each other, we want V and V prime to be as close as to each other as possible. So when we do numerical linear algebra, perhaps I will illustrate these cases. But for now, just keep in mind na though maraming bases, there could be an ideal basis to use in certain applications. Okay. And then let's jump to proposition 10. Proposition 10 tells us that another characterization of a basis. It says that a non-empty set V is a basis for V if and only if, that's why I said it's a characterization, kasi if and only if yung statement. Every vector in V can be written as a linear combination of elements of V in exactly one way. And it turns out na yung mga basis lang pala yung nakakagawa nito. So kasi kung meron kang isang set na nagge-generate ng buong vector space, hindi pala nagpa-follow na unique yung pagkakasulat ng mga vectors as a linear combination of elements of that set, unless that set is a basis. So this gives us another nice property about basis. Kapag sure ka na meron kang basis, unique lang yung mga scalars na makukuha mo in representing certain all elements as a linear combination of the basis elements. So let's try to prove this. Again, I hope you will help me recreate the proof in the handout. Para rin magkaroon kayo ng examples para sa proving. Right? Let's try to prove proposition 10. Again, it's an if and only if statement, so the proof should involve two parts. First, I'll assume that B is a basis. Then I want to show that every vector is written as a linear combination in exactly one way. And the other way around. I will assume that every vector is written in a unique way, implies B is a basis. Right? So let's do the forward implication. So here I will assume that B is a basis. And I want to show that every element is a unique linear combination of the basis elements. sabihin, unique yung mga makukuha mong scalars dun sa pag-represent ng mga vectors dun sa set V. Yun yung gusto kong ipakita. And usually, if you have a statement that claims there exists a unique thing, it is easy to prove it via contradiction. Kasi ano yung contradiction? Paano yung proof by contradiction? You will suppose that this is false. So ibig sabihin, I will assume that there are two ways on how to write a certain vector as a linear combination of the basis elements. And I will derive a contradiction from that. Okay? So, kasi parang mas mahirap na mag-show na unique yung pagkakasulat. Kasi I need to do two things. Find a representation and then prove that it is unique. I think you did that in one of the homework problems before. But now another flavor to it is to try to do a proof by contradiction. Now it says that every element is a unique linear combination, then I will suppose otherwise, right? So I will suppose the negation of what I want to show, suppose what I want to prove is false. So I will assume that there exists a vector V such that V is written in two ways. In terms of alphas, bi, I going from 1 to n, and at the same time, this is also equal to betas, bi, I from 1 to n, where alpha i's and bi's are in F, the bi's are in B, and alpha I is not equal to bi for at least one I. Okay? So, inassume ko na hindi unique yung linear combination expression or expansion para kay V. Suppose I can write V as a linear combination of the bi's using scalars alpha, and also it could be written as a linear combination of the bi's but with a different set of scalars bi. So for the ai's a bit different from the bi's, then at least for one I, magkaiba yung alpha I at saka bi. Okay? So ito yung negation ng unique linear representation. And from here, I want to derive a contradiction. So what do you think can be done next? Ano yung pwede kong gawin in search for a contradiction? Ano yung pwede kong i-contradict? Saan ako pwedeng humugot ng contradiction? Well, there's only one fact here that was assumed, the premise, na si B ay basis. So what do we know about B being a basis? Well, pinaka-basic definition. Si B ay linearly independent, at saka si B generates the entire vector space. Right? So the fact that B generates the entire vector space is already used here, because we said that the element V can be written as a linear combination of basis elements. So hindi ko palang nagagamit from the fact that B is a basis is linear independence. Alright? So ano yung form na pwede kong makuha from here na related sa pagiging linearly independent ng basis? Any suggestion what to do next? Yung clue. Ang iko-contradict ko, linear independence. So, ano yung kailangan ko para magkaroon ng statement related to linear independence?
Ang summation mo, sir, dapat equal to 0.
Right. So, kailangan
For
magkaroon pa ng
both
homogeneous
summations.
equation. Right? So, you're right. So, I can consider both summations. I can transpose this to the other side para magkaroon ako ng form na kamukha ng nasa definition ng linear independence. Right? So, what I can do here is that since they are both equal to V, then easily I can say that that the sum of the alpha i's bi minus the sum of the beta i's bi, I going from 1 to n, is equal to the zero vector, right? That follows directly from the previous statement, all right? And then I can use an earlier proposition together with
Sir, question, do you need the reason why you can, sir, do you need the reason pa when you do this proof, why you can transpose it on the other side? Do you use MPE or something? No more na.
hindi na. Pwedeng ganito na lang isulat nyo.
Okay po,
Kasi
thank
parang
you.
i-assume ko na natural na sa atin yun, na nag-a-add ka ng additive inverse to both sides,
Okay, sir.
nag-associate ka, nagko-commute, and so on, right?
Thank you, sir.
And then, all right. Then after this, I can use the distributivity of multiplication over addition, and then some earlier propositions to write this left-hand side as the sum from 1 to n ng alpha I minus bi equal to 0. All right? And this is more like a linear combination for us. It's a linear combination of the bi's with scalars alpha I minus beta I, right? But what is the implication? Remember, our assumption that bi's come from a linearly independent set. So what can we say about the scalar coefficients alpha I minus beta I?
The scalar coefficient, sir, is all equal to 0 because it's linearly independent.
Exactly, great. So that means alpha I minus beta I must be equal to 0 for all I from 1 to n because B is a basis and thus is linearly independent, right? And this means that alpha I is equal to beta I for all I, right? And that would be a contradiction. Where's the contradiction there? Because we said that dalawang magkaibang linear combinations itong dalawa na to. And we said that will happen if at least one of the alpha i's and the beta i's are not equal to each other. And yet here, we're saying that they must be equal to each other, right? And that's where the contradiction is. Okay? So that means if B is a basis, then it implies that every element, so therefore every element of B has a unique linear combination expansion, or maybe let's say a unique representation as a linear combination of elements of B. All right? But that's only half of the proof because we also need to prove the converse, okay? Yung reverse implication naman. So I will assume ito naman. So that would be my assumption. Then I want to show that B is a basis. Okay? Now I can use definition 6 in order to prove that it is a basis. Check the two conditions, all right? Now the second condition is easy because here it says that every element of B has a unique representation. So sinabi na sa assumption na lahat ng elements ni V ay pwedeng isulat as a linear combination of elements of B. So that's half of the conditions in definition 6. So maybe I should write condition 2 of definition 6 is clearly met. That is, the vector V is L of B, right? Kasi ang condition 2, dapat daw lahat ng vectors ay masulat mo sa linear combination of elements of the basis. But the assumption already takes care of that. Because the assumption here has a more restrictive condition. Sinabi niya na unique representation nga. Pero ibig sabihin, lahat ng elements ni V, pwede mong isulat sa linear combination ng elements B. So, tapos na yung condition 2. So what's left to be shown is linear independence. Okay? Now, we want to show linear independence. So now we consider a homogeneous equation elements of B and equate it to 0, right? Gusto kong ipakita na linearly independent, so kailangan kong ipakita na totoo to kung lahat ng alphas ay equal kay 0, right? But what will I use in order to show that? I will use this fact, right? So note na si 0 ay isang vector kay V. So kung siya ay isang vector kay V, ibig sabihin, si 0 vector, the right-hand side here, should be written as uniquely as a linear combinations of element of B. Pero kung isulat siya uniquely, may alam na ba tayo na solution ito? So we know this is true if alpha i's are equal to 0 for all I. Tama? Kasi kung lahat ng scalars ay equal kay 0, so that means ang summation na to equal lang kay 0 vector. Pero sabi ng assumption, lahat ng elements ng vector space ay masusulat mo uniquely as a linear combination. So ibig sabihin, the only way you can get a linear combination of the bi's to be equal to the 0 vector is when all the alphas are equal to 0. And there are no other representation of the 0 vector as a linear combination of the bi's. So that means this is not only true if alpha is equal to 0, actually it is true if and only if alpha I is equal to 0, due to the assumption that every element in a vector space, including the 0 vector itself, is uniquely represented as a linear combination of the elements of the elements of the vector space. Elements of the basis. Okay? Any questions? I hope clear yung proof. Or medyo mahirap yung second part kasi medyo obvious yung mga bagay-bagay. Because usually in math, the more obvious a statement is, the harder it is to prove it. But hopefully that makes sense. Okay. Now let's go back to module 2. I guess we're down to the last few results. Okay. Proposition 11. It just says here that V is a vector space over a field F, then every linearly independent subset B of V is contained in a basis for V. So, ibig sabihin, malilista natin lahat ng linearly independent into an inclusion tree. Pero yung nasa ibabaw ng mga tree na yon ay puro basis. Right? So remember the drawing I had for linearly independent sets. So it's proposition 11 tells us that the maximal elements in that inclusion should all be bases. Okay. Now the proof has some technical arguments from set theory. So hindi ko na siya sinama, and don't expect me to ask you to prove it. It is left as an exercise. I mean here as a reading exercise during your free time. Okay. The purpose of proposition 11 actually is for corollary 12, which may be expressed as a theorem on its own. Tapos tawagin ko nilang lemma in proposition 11, because this is one of the major results we have. Corollary 12 tells us that every vector space has a basis. Okay? Like siya may basis. The proof, I think, will require the axiom of choice together with proposition 11. It's a bit technical from the set theoretic point of view, so I will also admit this. But the beauty of corollary 12 is in the result itself. Na kahit ano pang vector space yan, meron siyang at least isang basis. Okay. So every vector space has a basis, and we have proven in proposition 10 that every element of the vector space can be written as a linear combination of the basis elements. That's why that unique representation, yung mga scalars dun sa unique representations na yun, ang tawag natin sa kanila ay yung coordinates ng vectors with respect to the given basis. Let me see. Or na-preempt ko pala siya, dapat mamaya ko pa siya sasabihin. So just forget I said that for now. I thought that was next, but okay. Example 29 is quite interesting kasi alam lang natin na lahat ng vector spaces ay may basis. Pero example 29 tells us that there is a very familiar vector space, the vector space of all real numbers, with the field Q as the underlying field and the usual operations. Alam natin meron niyang basis, right, by corollary 12. And a basis for this space is called a Hamel basis. But unfortunately, nobody is yet to construct a Hamel basis. Alam lang natin may nag-exist dapat na basis. Pero wala pang nakakapagsulat explicitly how that basis look like. That's why they are only called Hamel basis. But nobody knows how to construct such a basis or how such a basis looks like. So this is very fascinating kasi kilala natin yung vector space R. Kilala natin yung field Q. Pero nobody has yet to write a basis for this vector space with the underlying field Q. So if you will be able to find such a basis, then you will be very famous. So nobody is yet to do that. Yeah. Right, lemma 13, nasabi lang dito na if you have a finite, if your set V is generated by n elements, then any linearly independent set must have cardinality less than or equal to n. So if you know that the vector space is generated by n elements, then any set containing n plus 1 or larger elements is automatically linearly dependent. Okay. I included this proof as a homework problem, though I was trying to write a proof yesterday, but the proof, I guess, used a repetitive constructive argument, which might be a little bit tedious for you in the time frame that you were given. So I suggest you try last the homework that asks you to prove lemma 13. Okay. Now Golan, I saw Golan has a proof of lemma 13. The challenge actually is for you to rewrite the proof in your own way. So, but be mindful na may copy ako ng proof ni Golan. So what I'll do, if you chose to answer that particular homework problem, what I'll do is to compare your proof with Golan's proof and see how much of work you put into it, how much details you included, how well you paraphrased his arguments are, kasi highly technical yung pagkakasulat niya. So it will be great if you'll be able to laymanize or paraphrase Golan's proof without just copying it. So that's what I'm going to look for. Right? I included lemma 13 because of what is to follow, and this is one of the most important results in linear algebra. It's the dimension invariance theorem. It just says here that if you have two bases for the same vector space, then they must have the same cardinality. So sabi natin, if you, siya yung pinakamaliit and the number of elements of a basis is invariant. So hindi nagbabago yung number of bases. So now we can properly draw the inclusion tree for bases. So kung meron kang vector space dito, meron kang basis 1, basis 2, basis 3, basis 4, magkaka-same level lang sila dun sa inclusion tree. Kasi the invariance theorem tells us na magkakasing dami ang laman ng kahit anong basis ng isang vector space. And then I guess we have a proposition. Proposition 11 tells us that every linearly independent subset of a vector space is contained in a basis. So kung meron kang linearly independent set, say D1, D2, D3, and so on, malalagay mo sila sa ilalim ng isa dun sa mga bases na yun. Pwedeng andito si B4 and so on. So that's how the lattice diagram or the inclusion tree for linear independence look like. The bases are on top because they are the maximal. They are on the same level because they have equal cardinalities, and any other linearly independent set will be under one of these bases. Okay. And then we're almost done. Theorem 15. I just mentioned here the general dimension invariance theorem. This just takes care of vector spaces with infinite bases. So, posible kasi na ang vector space ay hindi finitely generated. So, Theorem 14 assumes that the vector space is finitely generated. Okay? So, kung siya ay finitely generated, then that means that magkakasing dami yung cardinality, or they will have equal cardinalities. But if your vector space cannot be generated by a finite number of elements, so dapat infinite yung cardinality ng mga bases, right? Then those infinities are equal to each other. Because the general dimension invariance theorem tells us that there exists a bijection between any two bases for P. So it doesn't matter if one basis is infinite, the second basis is infinite. General invariance theorem tells us that those two infinities must be equal to each other. Because probably you already know that there are levels of infinity. Some infinities are larger than certain infinities. So this theorem 15 tells us na magkakasing level yung infinity ng mga bases whenever your vector space is not finitely generated. Okay? And there's just a couple of examples here. And then some properties of bases, propositions 16 and 17. I just included them here because I'm thinking probably we will need them in future results. So that's why I just put them here. Okay. And I guess that completes our discussion about bases. So any questions? I hope kahit konti nakatulong yung discussion, though mukhang mabilis. Medyo mabilis kasi walang nag-react. So, okay, any questions? Before we go to homework clues and hints?
Sir, doon po sa, di ba sabi niyo po kanina, sir, may possibility na ang basis is hindi magkapareho.
Yes.
Do we still have to prove
Yes.
that, they are, independent of each other?
Well, totoo pa rin yun.
Or enough na yun na sinabi mo kanina, sir, na related silang dalawa?
Well, related in what way?
Kasi sabi mo, di ba, sir, kanina, if basis sila, medyo magkalapit lang sila. Parang ganon. Or yun yung
that's about
pagkaintindi
yung
ko.
stability.
Okay. So,
Hindi
but
sila
you still have
lagi
to...
magkalapit.
Yeah.
Posible
Because
kasi
I think...
yung basis 1 at saka basis 2 ay walang relation with each other aside from them sharing the same number of elements. So, the results we have so far, ang alam lang natin, yung mga bases ay magkakasing dami ang laman. Nothing more. So, yun lang yung alam natin. So, kung meron akong basis 1 and basis 2, I don't know what the relationship between those two bases is, but the only thing we are sure of, magkasing dami sila ng laman. Yan lang. Posibleng totally magkakaiba sila ng itsura, and so on.
So, hindi na kailangan i-prove that they are independent of each other?
Hindi na. Kasi, medyo malawak pag sinabi mong related to each other or independent to each other. But don't worry about that. There's no point in comparing bases kasi some bases, two bases could be totally different depending on your vector space. So ang mahalaga, we know that these two bases will have the same number of elements for now. Yan lang yung mahalaga sa atin for now.
Kasi I was asking, sir, kasi because hindi ko sure kung tama yun pa yung naalala ko. Wait, I think I have to read on that also. Meron kasing formula before that you can solve B prime, which is, another basis, using your old basis or yung kaya ba kasi sir may mga canonical basis yung mga 001, 010,
Yes.
100, which is for example for R3. So meron kasing formula I think in elementary linear algebra that computes B prime using your canonical basis. So kaya ka nagtatanong ako if kinakailangan pa yun or hindi na.
Yeah, you're right. Kasi merong mga processes na pag nagsimula ka sa isang basis, kakakuha ka pa ng panibagong basis. And maybe that's what you meant by related sila or independent sila sa isa't isa. For instance, pag meron kang linear transformation, which will be the coverage of module 3, pag kinuha mo yung image, isang basis pa rin yung makukuha mo. So, posible talaga na from one basis, makaderive ka ng panibagong basis. But for us, that doesn't matter for now, unless we go to module 3 or possibly also in module 4. But yeah, don't worry about that for now. So, ang alam lang natin, magkakasindami sila. And you're right, you can derive one basis from another, pero saka na natin problemahin. Alright, you don't need to prove anything like that for now. Okay? Alright, so other questions? So, punta na tayo sa pinakaantay ng lahat. Hints para sa homework. Okay. So, I suggest you try homework 3 as a last resort kung wala na kayong mapili na iba. If you cannot write a proof on your own, you can read Golan's. Kasi parang mas komplikado pa nga yung proof ko kaysa sa proof ni Golan. So, if you want and if you insist on answering number 3 and you cannot write your own proof, you can read Golan's and then try to paraphrase it and write it in your own favor. All right? But again, I'll compare what you have. So I beg you not to just copy Golan's work into your answer to homework 3. Okay. Now, anybody may nakapag-try na ba ng problem 4? So for problem 4, papakita nyo lang na basis itong set na to. You can use any of the information in the module so far. Pero siguro dito, I need to clarify one thing. It is a basis for M2 for this vector space over the field C. Kailangan yata field of complex numbers. So the scalar, if you will be going through the route of using the definition, papakita nyo na linearly independent ito, right? Yung set na yan, at ipapakita nyo na lahat ng vectors, lahat ng matrices ay kaya mong isulat as a linear combination of these 4 guys, alright? Yung scalars, pwede nyo kunin from the set of complex numbers. So we will assume that the underlying field here is the set of complex numbers. Okay? Kasi parang sa notation ko, para sa m sub 2 by 2 of f, parang hindi clear kung ano yung field, kung saan nanggagaling yung scalars dun sa vector space. So here you can take this as your vector space, and the scalars will be coming from the set of complex numbers. Okay? That's all you need to do. Medyo yung last sentence ay konting trivia lang about the last 3 matrices. These are the Pauli matrices which are usually used in quantum physics. Okay. Anyone who had a problem with question 4? I think question 4 is quite mechanical in nature. Pakita nyo lang na linearly independent, so isi-solve nyo lang yung homogeneous equation. Ipakita na dapat yung mga scalars ay equal to 0. The second part is to show that all vectors are all matrices is a linear combination of these guys. So pwede ka mag-start sa arbitrary matrix A plus BI, C plus DI, E plus FI, G plus HI, and show that this arbitrary member of this vector space can be written as a linear combination of these guys. Hanapin nyo lang yung scalars na magagaling sa set of complex numbers which will depend on A, B, C, D, E, F, G, and H. Okay? Is that okay? So, ano ba yan? Silence of type 1. So, clear ba yung gagawin sa problem 4? Okay, good. Problem 5. Here, we are considering the vector space of all functions from R to R over the field R with the usual function operations. The question is, pag kinolekta ko ba yung mga functions of this form, will it form a basis? And why? Okay. Have anybody tried this one? Okay, possibly a clue. So, what does it take for a set to be a basis? Number one, if I will be going by the definition, number one, the set should be linearly independent. So I guess it is easy to show, or with a little bit of work, you can show that this is linearly independent. Yung set ng lahat ng functions na ganito yung itsura. It's linearly independent. The second question is, can I write all functions as a linear combinations of these guys? And again, is that, remember how we define linear combinations. A linear combination should be written in this form. BI, I going from 1 to n. Yan yung definition natin ng linear combination. Dapat masulat ko siya as this summation. And this summation is finite. It ranges from 1 until n. Yun lang yung linear combinations. Alright? So kapag kailangan magtapos sa infinity, that's an infinite series. It is not considered as a linear combination the way we have defined it. Okay? An infinite number of terms. So, yeah, yun yung clue sa number 5. You will use that probably in showing that every element can or cannot be written as a linear combination of the FAs. Okay? And then I guess number 6 is also straightforward. You want to show that this is linearly independent. So meron ka lang 4 na polynomials, tuhin mo lang yung homogeneous equation. So equate mo lang yung linear combination nilang 4 sa 0 polynomial, and you show that all the scalars should all be equal to 0. So I think that's straightforward, that it is linearly independent. But the question is, how will you extend it to be a basis for the set of all polynomials of degree 5 or less? The clue has something to do with the exponents of 6. Remember, hindi lang linear independence, dapat lahat ng polynomial masulat natin as a linear combination of these guys. And then, take a look at if you can write all polynomials of degree 5 or less as a linear combination of elements of this set. At pag hindi kaya, ibig sabihin kailangan mo pang magdagdag ng isa or higit pa, whatever it is, magdagdag ng elements kay set A para maging basis mo siya. But that thing that you will add should preserve the linear independence. And then the new set should be able to generate P sub 5 bracket X. Okay? All right. Any other questions? Hopefully you found homework 3 a little bit easier, if not greatly easier than the previous 2. So again, the deadline was moved to Wednesday. Again, for those who have already submitted their work, the problems 4, 5, 6, without noticing the error I made in definition 6, you are free to resubmit your work. Just send me an email containing your updated work. Or you can also email me just saying na, sir, papalitan ko yung submission ko to follow na lang po so that I won't grade your submitted homework problems 1 to 6 for now. Okay? Because after the class, probably this afternoon and evening, I'll go back to grade the papers for homework 3 and all those submissions from the weekend. So para maging updated na ako. Wala na akong utang mag-checkan. Alright? Okay, other questions? Mukhang tahimik kayo ngayon. Walang masyadong paguluhan with the homework. So I hope that's because you found the homework at least easier. May not be shorter, but hopefully easier than the previous ones. And then again, try to find a way to download MATLAB because I'll try to have module 4 more numerical in nature. So magko-compute tayo doon ng mga matrices para hindi tayo kailangan magmano-mano. Alright? Okay, any other concerns, guys? Before we call it a day? Going once, going twice, going thrice. Okay, and with that, I hope you guys enjoy the rest of the day. Thank you for coming for our meeting today. And let's see each other again when? On Wednesday, same time, 11:30. And yeah, as always, just keep in touch via Teams or via email if you have some questions or if you realize something na medyo mahirap sa homework, alright? Okay, guys.
Thank you, sir.